This is part 3 of a series of NeuroSolutions tip boxes, where we will pick up from part 2 to further improve our results by reducing the number of inputs using the back elimination feature in NeuroSolutions for Excel, along with the user's level of NeuroSolutions, and then optimize our neural network topology for the optimal number of processing elements based on the reduced number of inputs. I have opened our previously saved Excel document with our training results from the Express Builder run. The first thing that we're going to do is attempt to reduce the total number of inputs to reduce the complexity of the network. This will provide a much leaner network since we're only providing inputs that offer the most information to the desired output. To do this, we will use an input selection technique called back elimination. For more information on back elimination, please visit our website and view the video Input Selection Method, Greedy Search, and Back Elimination. Probabilistic neural networks, or PNNs, are great for quickly processing these sorts of tasks, so let's go ahead and create one real quick. To do so, click on the NeuroSolutions menu, click on Create Open Network, New Custom Network. Next, we will choose RBF GRNN PNN Network. And we also want to check the regression probabilistic checkbox. And then click through the panels and click Build. Before we can run back elimination, we will need to save this breadboard. Now we are all set for our input optimization. Back elimination can be found in the NeuroSolutions menu under Train Network and Train Genetic. In this dialog, select Back Elimination from the drop-down menu Input Optimization and click OK to continue. This process took approximately 10 minutes to run, so we'll go ahead and view the results now. What the results display is the best MSE for each generation, where the best generation came on number 16 with a final MSE of approximately 0.004. To see which inputs are kept, we can go back to our original data sheet, and anything that is grayed out has been disabled, and anything that is still highlighted with black text is still enabled. So it looks like that we've kept columns or inputs 3, 5, 6, 10, 11, 16, 17, 20, 22, and 24. So now that we have our reduced set of inputs, let's go ahead and work on optimizing our network itself to do a little bit better. To do that, we're going to use the Vary a Parameter feature in NeuroSolutions for Excel, which is located under the Train Network menu as Vary a Parameter. In the Vary a Parameter dialog, we want to find the optimal number of processing elements for our one hidden layer. We will start by changing the start value to 1 with an increment of 1 and a number of variations to 10. This will try every variation between 1 and 10 processing elements. This process will take approximately 10 minutes to run, so we'll go ahead and skip ahead to see the results. So let's go ahead and take a look at our results from the Vary a Parameter run. The results came back to determine that 3 processing elements was the optimal number of processing elements for this particular problem. What we can do now is see how the testing results from the various changes that we've made by reducing the number of inputs and also optimizing the breadboard to fit this particular problem. To run the test, we'll simply go to the NeuroSolutions menu, choose Test Network, and test. All the defaults for this particular panel is fine, so we'll go ahead and press OK. Briefly looking at the results, we can determine that we improved the percent correct on both the hyperthyroid and the negative classes compared to the original Express Builder run. Specifically, the hyperthyroid improved by roughly 30% compared to the original Express run, and the negative class improved by about 1%. You can get these percentages from down here in this table. However, We are still not classifying correctly the Gautier or the T3 to XLC classes, which means further work can be done to improve these results, such as weighting the outputs in NeuroSolutions, trying alternative input reduction techniques, or gathering more samples for those particular classes. That is all for part 3 of the From Data to Model series. In part 4, we will briefly discuss the custom solution wizard and deploying your solution to your own application. We'd like to thank you for taking the time to watch this tip box,